In this video, we'll simplify the concept of hierarchical deterministic wallets and highlight their relevance in the world of crypto. Let's get started. Cryptocurrency addresses. To first understand the importance of HD wallets, we need to understand how addresses work in cryptocurrency. If you think of your cryptocurrency account as similar to an email account, in cryptocurrency, you have an equivalent to an email address, and we call it a public address. Your public address is comparable to an account number. It's visible to the public, and anyone can use it to send you cryptocurrency. It's a unique combination of numbers and letters that distinguishes you from others. Now, consider your email account. You have a password to access and read your emails. In the cryptocurrency world, you also have a password, known as your private key. However, its purpose is not to view, but to facilitate the transfer of cryptocurrency from your address. With email, we create an email address and then select a password to use it. In contrast, with cryptocurrencies, we generate a private key. The public address is derived from this private key through a mathematical algorithm. Pseudonymity versus anonymity. A common misunderstanding in the world of cryptocurrencies, which often goes unnoticed, but it's crucial to grasp, is the concept of pseudonymity versus anonymity. Pseudonymity, in the context of cryptocurrencies with public blockchains, means that your real-world identity remains disconnected from your transactions. Instead of your name, transactions are linked to a unique pseudonymous address, akin to having a username in the digital currency world. The challenge with cryptocurrencies like Bitcoin is that it operates on a public blockchain, meaning that anyone can view all transactions and their respective addresses, but they can't discern the real identities behind those addresses. The potential risk arises when one reuses the same address for multiple transactions. If this address becomes associated with your identity, it exposes your complete transaction history. Others can start piecing together your financial activities and potentially compromising your privacy. Imagine a scenario where every transaction uses the same address. Then when you buy a coffee, the person who you purchased the coffee from could then, using this wallet address, look up and see all your transactions. You would never show your bank statements whenever you made any purchase for the person you're buying from to inspect. Recognizing the implications of pseudonymity, many cryptocurrency users now opt for a different address for each transaction. This simple practice bolsters their privacy, making it more challenging for prying eyes to track their cryptocurrency holdings and financial actions. Hence, the decision to use a new address for each transaction isn't just a matter of convenience. It's a deliberate step towards preserving your privacy and empowers you to maintain control over who has access to your transaction history. Creating a new private key for each transaction. You've made a wise choice to prioritize your privacy in the world of cryptocurrency. You're opting for a new address for each transaction, which means your wallet will generate a fresh private key every time you initiate a new transaction. Implementing this approach entails your cryptocurrency wallet creating a unique private key for each transaction. Using a new private key for every transaction indeed introduces a logistical challenge. Each key requires secure storage, and losing or misplacing any of them can have severe consequences. This is where the significance of backups becomes evident. For every new private key that's generated, it's critical to maintain a reliable backup. The reason is simple. If any of these keys are lost or become inaccessible, you risk losing access to the cryptocurrency stored in the associated address. This highlights the paramount importance of maintaining reliable backups for every new private key. What is an hierarchical deterministic wallet? The process of creating a new address for every transaction can be cumbersome and complex, especially when it comes to managing multiple keys. That's where the hierarchical deterministic wallet, or HD wallet, comes into play. This ingenious technology was introduced to offer the benefits of multiple addresses without the logistical nightmares of juggling numerous keys. At the heart of HD wallets lies a single, crucial element, the seed phrase. This seed phrase serves as the foundational point for generating all your addresses and private keys. Using this seed phrase, HD wallets employ a deterministic algorithm, a set of mathematical instructions, to create a hierarchical tree of addresses. This is where the magic unfolds. The hierarchical structure is the linchpin of HD wallets. It empowers the creation of a multitude of addresses while maintaining a central point of control, your seed phrase. This structure establishes a parent-child relationship, with the seed phrase as the parent. Whenever you need a new address for a transaction, your wallet follows a predetermined pathway from the seed phrase to craft a unique address and its associated private key. The address derivation path adheres to a standardized format, known as BIP32. This standardized path ensures compatibility across various wallet implementations, ensuring seamless access to your addresses. HD wallets also simplify the backup and recovery process. You only need to safeguard your seed phrase. This eliminates the logistical nightmares of having to back up each new key every time you create a new address. With just the seed phrase, you can reconstruct all your addresses and private keys if your wallet is ever lost, or if you decide to migrate to a new wallet. Mnemonic code. The seed phrase essentially represents an extensive random number, typically displayed as a combination of numbers and letters. Attempting to memorize or manually transcribe it as a backup can be error-prone, potentially resulting in the loss of access to your cryptocurrency holdings. To address this challenge, mnemonic codes were introduced. They consist of a set of human-readable words, usually 12 to 24 in length, carefully selected from a predefined list. These words serve as a user-friendly representation of your seed phrase, simplifying the process of creating backups and recovering your keys. These words are not randomly chosen but are part of a predefined word list, typically a standardized collection of words used in creating mnemonic codes. This list is carefully curated to ensure that each word is distinct, and that there's minimal room for ambiguity or confusion. Users can trust that these words are consistent across various wallet implementations and adhere to a common standard. Each word within a mnemonic code represents individual bits of data that, when combined, form your seed phrase. Now, there's a crucial additional step in this process of translating words into the seed phrase: checksum validation. This step is vital in ensuring the accuracy of the seed phrase and acts as a safeguard against potential errors. A checksum is a piece of data derived from the words within your mnemonic code. Checksums function as a safety net. When you input your mnemonic code into a compatible wallet, the software performs a checksum validation. It recalculates the checksum based on the entered words and compares it to the original checksum. If they do not match, the software recognizes that the mnemonic code is not valid, indicating a potential error. Thanks for tuning in to learn about HD wallets. If you found this video useful, consider giving it a thumbs up to show your support. Got a question or an idea for a future video? Drop them in the comments below. See you in the next one.